Hello, ladies and gentlemen. Welcome back to Math 20-2, Chapter 3, Trigonometry, Section 4, Solving Problems with Acute Triangles, Part 2. So, Brendan and Diana plan to climb the cliff at Dry Island Buffalo Jump. They want to know the height of the cliff before they start. Brendan stands at point B as shown in the diagram. He used a clinometer to measure angle ABC, the angle of elevation to the top of the cliff. Now, note the drawing here. It's on the next page for me. You guys should have the notes in front of you where you see the drawing. Anyway, he then estimates angle CBD, the angle between the base of the cliff and himself and Diana, who was standing at point D. Diana estimates angle CBD, the angle between the base of the cliff, herself and Brendan. So there's the numbers there. Determine the height of the cliff to the nearest meter. We want to find the height here. How do we do that? Well, once again, what we have, two triangles. We have this one here. Now, I'm going to move this over here, make it a little bit smaller. This angle is 76 degrees. We also have this triangle here. Oh, you shazbot. Stop that. People are watching. Make it a little smaller for safe space. Take that just a minute. You Wiener Schnitzel. So this is 60. This is 50 degrees. This is 60 degrees. Now, I find once you split it up, it's not so bad. Because you need this side of this triangle, which becomes the base of this triangle. And once you have the base, you have an angle, you can figure out the height. So, looking at the black triangle first, I have to figure out this side. I'm going to call it x, because I can. Right? Now, notice that is opposite 50 degrees. And, oh dear, I need the angle opposite. If I'm going to use the side, sorry. I don't, 50, 60, try that again. Sorry, ladies and gentlemen, I did some stuff in my head and I didn't speak it out loud. I was looking at this, I'm going, this angle here, 180 degrees minus 60 minus 50 is 70 degrees. So this is not a right angle triangle. So I can't use standard sine, cosine, tangent. I can't use Mr. Pythagoras. But what I have got are two angles inside in between. I cannot use sine law, so I'm down. Sorry, I can't use cosine law, so I'm down to sine law. So 60. I have 60 opposite 70 degrees. I have 50 degrees opposite x. So I can go looking for side x. That is a over sine of a equals b over sine of b. In this instance, it's x over sine of 50 degrees equals 60 over sine 70 degrees. So, Mr. Calculator, on, the other on, mode, still in degree, good. 60 sine 50 divided by sine 70, 48.91. Now I'm going to be using that number in another calculation, so I'm not going to round it off too much. Now, this is 48.91, and I'm looking for the opposite side to that angle. So what have I got? Here I have a right angle triangle. Notice I said it was a right angle here. I forgot to draw that there. And you're looking at this in an angle, so it's kind of not the best drawing, but use your imagination. You know that thing the internet is destroying? Anyway, so opposite and adjacent and an angle in a right angle triangle, this is the adjacent, is tan. So tan of theta is opposite over adjacent. Now, rearranging this to solve for the side, it is opposite is adjacent tan theta. Or my height, my adjacent, 48.91 times tan of 76 degrees. And when I plug that into Mr. Calculator, times tan 76, 196.77. Now, 196 meters. Okay. Now, for my crude drawing, is that reasonable? Well, honestly, my drawing isn't very good because you're looking at it from an angle. But if this base is 50, or 48.91, 76 is fairly sharp like that. So this being 196 is not unreasonable. But once again, I don't... Actually, I do have a protractor here. Let's see if I can get it to work down here, because it's a poopy head at times. Oh, so it's not even close. 76 is... You're going to be like that, are you? Sorry, 76 is there. So yeah, I didn't draw that very good. I'd be like that. Put a point there. And get rid of this thing. The reason I don't like this protractor. So 76 is actually more like that. So yeah, 5 times as high. So 296 for the opposite side is reasonable if I drew a decent diagram. All right. Now, last question. Or is it the last question? Please tell me it's the last question. These are nasty and long. Yes. Now, Brian is in a police helicopter 400 meters directly above the Sea to Sky Highway near Whistler, BC. When he looks north, the angle of depression to a car accident is 65 degrees. When he looks south, the angle of depression to the approaching ambulance is 30 degrees. How far away is the ambulance from the scene of the accident to the nearest tenth of a meter? Okay. So, draw a picture. I didn't give you a picture here, but he's 400 meters up. He looks north, and he sees the angle of depression to a car accident is 65 degrees. So, degrees. Looking south to the ambulance, it is an angle of depression of 30 degrees, so it's farther away. So what is this distance d? Now, point out he's straight above, so it's 90 degrees. Okay, so what we have to find here is the total distance of the base of these two triangles. And I will point out this is parallel to this, so this is 65 degrees. This is 30 degrees. So what we have a height, the opposite for both these angles, and we're looking for the adjacent. So, tan theta is opposite or adjacent. Or rearranging this, opposite equals adjacent, tan theta. So the opposite is, let's do it for the 30 degrees first. 400 meters is, I'm going to call this x times tan of 30. How do I get rid of times tan 30? Divide both sides by tan of 30. So x equals 400 divided by tan 30. (692.8 meters). So this is 692.8. Now, what about over here? For the 65 degrees. Well, it's going to be opposite equals adjacent. Tan theta again. I'm too lazy to prove where that comes from. That's 400 equals, I'm going to call it y. Why not? times tan of 65. Divide both times size by tan of 65. Y equals, wrong one, sorry. 400 divided by tan of 65. 186.5. That's 186.5. Add those together, you get a total of plus 879 meters. 0.88 of a kilometer. Okay? Now it's going to the nearest tenth of a meter. All right, so oops, screwed that one up. Sorry. Double checking the question, which you always should do 879.3. I wouldn't go to a tenth of a meter, but that's what the question says. All right? See how that goes? Good. Now, last part. The ambulance is traveling 80 kilometers an hour. How long will it take the ambulance to reach the scene of the accident? More of a bonus question. Velocity is displacement over time. Now, I feel like rearranging this like a physics question. Time is displacement over velocity. The displacement is 879.3 meters. 80 kilometers an hour. Turn that into kilometers. And of course, why is the calculator always where I don't want it to be? Divided by 1,000 is 0.9. Divided by 80 is 0.01099 of an hour. Now, times 60, 0.66 minutes. Times 60 seconds in a minute. We're looking at about 40 seconds. So that's about 40 seconds out, which is a long time. Well, I shouldn't say that. I've been traffic accident, hour plus for the ambulance to show up. So anyway, so 40 more seconds. Now this is more of a bonus question, but rearranging math equations, always a good idea. And you should know velocity is displacement over time. Now finally, key ideas. The sine law, the cosine law, the primary trigonometric ratios, and the sum of the angles in a triangle may all be useful when solving problems that can be modeled using acute triangles. What you need to know is to decide whether you need to use the sine law or the cosine law. Consider the information given about the triangles and the measurement to be determined. So can you get away with sine, cosine, tangent, Pythagoras, or do you have to use sine law and cosine law? All right, good question. That you have to decide by working on the question. So now's a good time. Go to the classwork and practice it, please. Any questions, shoot me an email. Otherwise, good luck.